Okay, let's finish up section 4.1. This is the last little piece. This is on arc length, and you'll need this for your WebAssign. All right, I want to begin by kind of bringing back a picture that we looked at today in class, and that is that if you have a circle, and this circle's got an angle, then we can identify three parts of this picture that we're going to need for our current formula. This is the radius of the circle. R equals radius. This is called the arc, just the little curved part right there, pizza crust. And for some reason we're going to abbreviate it with the letter S. S is equal to the arc. And then this right here is going to be called theta. And theta is equal to a central angle, which is just what its name says. It says an angle with a vertex at the center. So these are the three parts of our formula. And the formula itself is this, that if you want to find the length of the arc, S, you can multiply the radius times the angle theta. S is equal to r theta. This is the formula for the length of the arc. Now, two things you should know about this formula. First of all, this angle theta has to be measured in radians, and that the length of the arc will be the same unit, inches, feet, centimeters, whatever, as the radius. So if your radius is 5 inches, your arc length is going to be measured in inches. Okay, now there are three applications of this. That is, there are three parts to the formula, the S, the R, and the theta. So we can find each of these parts, and I've got an example of each, and then we'll be done with this video. So here's the first picture. Solve for S in this picture. Your radius is 8 inches. Your angle, your central angle, is 110 degrees. So because this radius is in inches, this arc length will be also measured in inches. So our formula is S is equal to R times theta. Obviously the R is 8 inches times. Now our theta is 110 degrees, but as I told you, you've got to have your angle measured in radians. So this is the formula we discussed today in class. 110 degrees, we need to turn it into radians. So we're going to say 110 times, we're going to go with our pi, and then we're going to divide that by 180. And we're going to change that to a radian measure, and it is going to be approximately 1.919. And you can take that as far as you want. It's actually 1.91986 ... So I'm going to say that's approximately 1.9 radians. So I'm going to go back to the formula, and I'm going to say 8 times 1.9 radians. Your instructions for rounding will be included in your problem. Multiply those together, and this is 15.2. And then we go pick up the unit from the radius, which is inches. And so the arc length here is 15.2 inches. Now, let me just point out something to you. You remember today in class when we were talking about what is a radian? And we said a radian is the amount that is formed when the radius and the arc are the same length. Well, one radian is approximately 57 degrees. You see this angle? This is 110. This is over 2. This is almost 2 radians. And you notice this arc length is almost 2 times 8. If that were 57 degrees, that would have been pretty close to 8. It's almost twice that, so this arc is almost twice that. So this arc is 15.2 inches. Second example I have is to solve for the radius itself. Look at this problem. There's your slice, 40-degree angle, 10-degree arc. S is equal to R times theta. Let's fill in. We know the arc is 10. We don't know the radius. And the theta, 40 degrees, we need in radians. So let's take that, 40 times pi over 180. Multiply across. Divide by 180. And that turns out to be 0.698. I'm going to just say that is approximately 0.7 radians. Again, you know, you'll know how much to multiply by. So 0.7 radians. And then all I have to do to solve is to divide 10 by 0.7. And it looks like my radius is approximately, let's just go to tenths, 14.3. And we'll pick up the unit of the arc, which is inches. So the answer is 14.3 inches. Okay, now again, remember, if this had been 57 degrees, these two would have been about equal. This is less, so the arc will be smaller than your radius, and there's your radius, 14.3, so that makes sense. Finally, here's your third problem. Here is solving for the actual angle itself. S is equal to R times theta. S, the arc length is 12, is equal to 9 times theta. Now theta equals 12 divided by 9. This is an answer that turns out to be 1.3 repeating. So let's just say about 1.3. Now that is in radians. The angle has to be in radians when you use it, and when you get it out of this formula, it's in radians. Suppose we wanted to change that to degrees. We'll take the 1.3 radians, multiply it by pi on the bottom, 180 on the top, because you know radians will cancel radians, and just multiply across 1.3 times 180, and then divided by pi, and we get approximately 74.5 degrees. And does that make sense? If that's a little more than 57, then this should be bigger than 9, and that is true. So our angle in degrees is about 74.5. All right, this is just a brief lesson on the arc length formula. S is equal to R theta. We've solved for S, we've solved for R, we've solved for theta. That's all you have to do with that. I think this will help you with your WebAssign, and that finishes section 4.1. Thanks for listening. See you tomorrow.